Hello there. My name is Max Smolaks, editor at AI Business, and in this Experts in AI interview, we are going to talk about quantum computing. We will discuss the potential of quantum computing, find out about some of the business applications that are available today, and look at the crossover between quantum and artificial intelligence. Lending us their expertise is a team from Reply, a leading consulting, systems integration, and digital services company. So I'm pleased to welcome Sara Felloni, Quantum and Accelerated Computing Manager at Reply. Hello, Sara.
Hi, happy to be here.
And Johannes Oberreuter, Data Scientist and Quantum Computing Practice Lead at Reply. Johannes?
Hi, Max. Thanks for having us.
So let's get straight into it. So first of all, some people might not be intimately familiar with quantum computing. So Johannes, could you give us a short introduction to the subject? So how can quantum computers solve problems that classical computers are struggling with?
Yes, I'm happy to. So if we talk about problems which classical computers, like normal computers, are struggling with, we are really talking about what computer scientists call complexity. So the point is, if you have a problem described by a number of variables, say a number of cities you want to visit on a trip, then the problem becomes not just a little bit more complicated if you add another city to your schedule, but it becomes twice as complicated, or doubles in complexity every time you add a city. And this is what we call an exponential complexity. And you can, now we all know what exponential growth is, right? So you can imagine that at some point, and you don't need a lot of variables for this, this becomes really intractable in terms of memory, in terms of computing time, in terms of these things. And the problem is that this is not something you just solve by making the processor a little bit quicker, a little bit faster, because the exponential growth runs away, right? So this is why this new paradigm of quantum computing might be useful. The point of quantum computing is that rather than having as a fundamental unit of information the bit, which can be either 0 or 1, you have a qubit, a quantum bit, which is the equivalent of a bit in quantum computing, obviously. And it can be something in between 0 and 1, and it can use this peculiar property of quantum mechanics, which is called superposition, of being in two states at one time, roughly speaking. So why this is interesting is because of this being in two states at the same time, a qubit can represent a larger space of computation, so to speak. So if you have one qubit, you have like 2 states. If you have 2 qubits, you double this. You already have 4 states. If you add another one, you have 8 states, and so forth. And you already see the dimensionality of this space in which qubits live also grows exponentially. And this gives you a hint that for these exponentially complex problems, an exponentially growing computational system is useful. So the catch here is that it's not just like you're exchanging your processing unit in the background and everything works. You really need to also rethink your algorithms. So not everything which you know, the standard way of computing stuff will work the same on a quantum computer. You really have to rethink how to formulate your problem, how to program it. And also not for all problems we do know a suitable quantum algorithm. So we really have to also figure out, and we know, of course, because there has been a lot of research in this field, for which problems quantum computers can be useful.
Mm-hmm. And exactly, and one of these problems is encryption and generally cybersecurity. So experts are especially concerned that quantum computers will allow us to decrypt a lot of stuff which is considered completely safe right now. So why are experts concerned?
Yes, this is exactly one of these examples. A lot of the today's encryption formalisms and strategies rely on an asymmetry in complexity. So you do an operation one direction, it's really easy, and you do it the other direction, it becomes hard in the sense which I described just before. And that means if you want to encrypt something, you would just multiply, say, two prime numbers, say, well, I don't know, 9 times 7 or so, which is 63. It's an easy operation, everybody can can do it, right? But if I ask you what are the factors of 63, how would you decompose this? You have to start thinking, right? Okay, 2 doesn't fit. Okay, then maybe 3. Does 3 fit? Yeah, maybe you remember this rule. Okay, it starts to become tricky, right? And I mean, if you know the answer, it's easy. But if you do not know the answer, this takes a long time. Of course, 63, everybody can factorize in a really short amount of time. But what people do in encryption is they take really, really big prime numbers and multiply them together. And then precisely because of the complexity of the exponential complexity, this takes a really long time. So in case of RSA 2048, for instance, I think it's something on an ordinary hardware, it will take you 10 to the something 15 years or so. That is substantially more than the age of the Earth, which is roughly 10 to the 9 years, right? And if you would, even if you take a supercomputer, a cluster or something, this becomes faster, but it doesn't become a lot faster in the sense of it doesn't become useful. So in this sense, your secrets are safe, right? Because if it takes the age of the Earth or longer than the age of the Earth to decrypt something, well, who cares? I don't mind what happens in 10 to the 9 years, right? I'm not around anymore. Now the point is, if you have a quantum chip, and we do not have a quantum chip which would be as capable today, but we might have it in 4, 5, 6 years. And that's what people are afraid of. This changes substantially. And what has been the age of the Earth now becomes 2 weeks. And if you have an even larger processor, it might become a couple of hours, right? So there are some estimates out there. And the crucial difference is 2 weeks. That starts to become dangerous, maybe not for all of the operations, but for some things are then likely to be exposed. And I mean, this is on the one side scary and tricky and difficult, and people should be aware of this, so that this will happen in a couple of years, or can happen in a couple of years. On the other hand, it just shows you the dimension, like something which takes the age of the Earth is possible to do in a couple of weeks. This shows you that completely new problems which were unsolvable before can become solvable now. And this is, for me, this is fascinating, and also a reason for hope.
Exactly. So this is a very, very interesting application, but it's coming years, possibly even decades down the line. So I have a question for Sara, a little bit more practical question. So Reply is obviously very involved in quantum computing, and you offer, services for business today. So what can you do with quantum for business today, and which sectors lead the adoption of quantum computing?
Of course. So yes, among the most promising quantum applications for business today, we can surely mention quantum optimization, quantum security, quantum machine learning, quantum simulation for finance, chemistry, and pharma. Several sectors are in fact leading research and investments in quantum computing today for several purposes. So we have finance and insurance, logistics, energy, supply chain, and manufacturing among the first one investing and pushing further investment in this technology. So all these sectors have in common many core tasks or transactions which are run by algorithms where complexity is always a huge obstacle and where reduced computational time is of critical importance for the business processes. And quantum applications today are addressing several of these fields and of these aspects. I can give you some examples. So for instance, as Johannes just said, in cybersecurity and cryptography, quantum computing can help prevent or address the increasing cyber attacks where impractical or impossible for classical computers and communication protocols. And quantum computing, with the help of machine learning, can help in developing various techniques to combat these cybersecurity threats. And additionally, quantum cryptography provides new encryption methods whose security is guaranteed by the laws of quantum mechanics. While in finance and insurance, quantum computing helps to find the optimal approach to investments based on expected returns, on the risk associated, on cost and loss reduction, and other relevant business factors. For instance, Monte Carlo simulation and algorithmic trading are widely used today despite being very challenging for classical computers. And by applying quantum technology to perform these massive and complex calculations, companies can improve both the quality of the solutions and the time to obtain them. And when handling billions of dollars, even a tiny improvement in expected return can be worth a lot. So you can guess the importance of application in this area. And finally, We have logistics, supply chain, and manufacturing, and a wide range of industries that need to optimize their logistics and scheduling workflow. So in these areas, operating models need to continuously calculate and recalculate optimal routes of traffic, fleet operation, traffic control, freight distribution, staff scheduling, and so on. And all these processes have severe impacts on the business. And so in these areas, quantum annealing and quantum optimization can offer advanced optimization techniques that are already surpassing traditional computers in terms of both computational speed and solution accuracy.
Okay, thank you very much. So lots of interesting stuff there. And you've mentioned quantum machine learning, and us on AR Business, we're obviously very, very interested in this crossover between quantum and machine learning. So Johannes, could you talk us a little bit like why should machine learning specialists be excited about quantum computing? What new things can they do with quantum?
So machine learning is already quite advanced and has a lot of applications, right? There are various problems though which you might encounter. So one problem is, of course, you want, as Sara said, you want the accuracy of your machine learning model to be as high as possible, right? And some methods there, I mean, you always have to represent your data in some way, and the representation might not be ideal. What quantum computing allows there is, because it is faster, it is more efficient to calculate some functions. It allows you to calculate a representation of your data in some circumstances, which is more suitable for subsequent classification or whatever you want to do with them. That means because you have a better representation, your end result, the business goal you want to achieve with your machine learning model is achieved to a better degree. The nice thing is that, and surprising thing to me, that you can already get nice results with only a few qubits. So you might have heard that, quantum computing, they're really small. You just have a couple of qubits. You don't, it's not yet ready. As we said before, you have to wait for a couple of years. But we have systems with like 10 to 30, 70 qubits, something like this. And already with a couple of qubits, you can really achieve improvements. And one thing which I find particularly also useful and interesting is that you can combine advanced machine learning methods like neural networks, deep learning methods, with quantum processing units. You slot in between your neural network layers, you slot a quantum layer, and this allows you to do other calculations, other processing steps on your data, which sometimes improve the result you get. Of course, I mean, I say sometimes in some cases that is the point, that very often machine learning will give you good results, good enough results. So the art here is to really find and figure out the cases where you struggle and where more accuracy, a better representation is really useful because you need it for your business goal, or because the representation and the model you have at the moment is not good enough.
Yeah. It's not going to be picture classification, like it has to be like a worthy cause. Okay,
definitely.
and Sara, you mentioned techniques like quantum annealing. So like there's a lot of hype about quantum computing, but like there's like a full-on, like 100% legitimate quantum machine will need like absolute zero temperatures. It need to be, like we've seen these pictures, like it's giant kind of setups, lots of piping, lots of, like coolant. But not all quantum computers actually need that, right? So how do you make quantum practical? How do you take it to the business users? And what does it mean, like things like quantum annealing or inspired by quantum computing? So yeah, could you talk us through the options?
Of course. So first, we identify the areas of quantum computing which can deliver practical business application to organizations right now or in the nearest future. And then we basically develop expertise to address real business problems by choosing among all the available technology and algorithms what is most suited to the problems today. For instance, we focus our effort in hybrid computational model, as you were saying, as this model combines quantum and classical computing to make the most of both worlds and to overcome the technological limitations that are still affecting quantum hardware in its journey to reach the full maturity and market readiness. And also, together with our customers, we identify the business use case where hybrid computing and quantum-inspired computing can bring measurable and significant improvements to their business processes today. Quantum optimization in particular is very suitable to introduce quantum computing to customers, to let them realize that quantum computing is not just a strange and complex technology, but an innovative approach to do the business they are doing today, but faster and with better results. And thanks to the advancement we are seeing every day in both quantum annealing and quantum computers, we are no longer confined to theoretical research. We are already tackling real business problems with quantum hardware, but with the aid of classical hardware in this hybrid and quantum-inspired approach. So what means quantum-inspired approach? Quantum computing is a way of conceiving computing software as well as computing hardware by harnessing the law and the power of quantum mechanics to solve very complex problems. Quantum-inspired solutions are a way to start applying quantum computing despite the implementation challenges we were talking about before. So this is made possible by exploiting classical special purpose hardware that is market ready and available with approachable costs today, such as GPUs, graphic processing units. And the behavior of such hardware is very similar to the behavior of quantum computers, so that quantum solutions can run with the same parallelization and efficiency on this classical hardware without loss of computational power. So quantum-inspired computing can generate some of the benefits expected by the future fully developed quantum computers, and it can do this today for special classes of computational problems. And these problems include efforts aimed at solving larger and more complex combinatorial optimization problem, where you have to find the maximum or minimum solution from a large set of possible combinations. And these problems are also very common across industries. So in synthesis, first, with quantum-inspired solution, we can solve problems today that can be solved with general purpose classical computers. And that also can be solved with quantum computers yet. Second, any algorithm developed on quantum-inspired computing platform can be reused on future quantum computers when they reach a suitable level of maturity and are available on the market. There is no throwaway of development work and no loss of efficiency in this transition. And finally, quantum-inspired solutions can also stand on their own now and in the future. You could choose to transition to actual quantum computing, to quantum hardware, when the right moment comes, or you could also choose to maintain your quantum-inspired approach on your classical hardware out of business and investments consideration, and you would have powerful solution in both cases.
Okay, thank you. And I'm gonna slightly reword this last question. So again, I've spent 3 years reporting on AI, and in AI there was this early mover advantage. You know, like the people who got on the AI bandwagon, like right at the beginning, they are almost impossible. It's very, very hard for their competitors to catch up, because there is this, you know, like you start building up expertise, you start building up the knowledge, skills, and yeah, it's just like without making huge investments, it's going to be very, very hard to get, you know, like over that first mover advantage. So do you envision that something like this is going to happen to quantum, that they, you know, like, okay, it might not be suitable for all business cases, but it's worth getting involved in quantum today just to get your, you know, you get your stake in, basically start developing these competencies for when it really becomes like, you know, like a business critical aspect of your infrastructure. So yes, Johannes, do you think that quantum is at that stage right now? And you know, like, would we say businesses need to get involved for this reason, if not for any other?
I definitely think so. I mean, what Sara just explained very nicely shows us that getting into the game now is not a bet on the future, but it's already delivering some of the value that you can achieve with quantum computing now. So that alone for me is a reason why businesses should move into this field. And the advantage is going to get better as the hardware gets better, right? Then there are other cases, as we said, with machine learning, where it's maybe not so clear yet and a bit more difficult to tackle or to reap the advantages. However, this will come. And if you look at the roadmaps of all the major vendors, we see that it's around the corner. I mean, a couple of years is around the corner for big developments, right? And it definitely takes some time to build up the knowledge and the expertise within your organization, because it's not only that you hire a quantum physicist, a graduate from some school. You need this knowledge both in computer science or in computing and data science, and the domain knowledge, and the understanding of how to deal with a quantum computer and what to do differently and how to learn this. So this takes some time in terms of culture, also in terms of awareness of the organization that this technology is there and what it can do and what it cannot do. Because if you just have a person sitting there and having the knowledge but no applications for it, it's pretty useless, right? And as you say, building up your data pipelines and your organization and the organizational awareness, as I said, that you should prepare for this, and you should prepare your data and your business processes to integrate these opportunities. The quantum opportunity, I think, will definitely take a while. So we've been dealing with quantum computing for a couple of years now, and I definitely remember that in the beginning it was pretty difficult to understand what's going on at all. Of course, this was a time when there was no material out there, right? We only had academic literature which we needed to understand and implement and test and bring to the practice and make our own experiences. And of course, now with a lot of public awareness, the situation is easier. But still, it is. I would say it's not as easy to get into this, and definitely to reap the return on investment. It will take a while, obviously. And I would definitely recommend to consider if this is not the time for your industry to start with it, especially for what Sara explained.
So this is very interesting, but how do businesses make the first step? So let's say one of our viewers has listened to this, has found this interesting, and now they want to find out, so where do I find the expertise? Where do I find the partners that can, help me on this journey? Because I don't know what I'm doing. And let's be honest, it's very early days. Nobody knows what they're doing. So yes, how can businesses take first steps with quantum computing? Sara?
Okay, yes. Quantum computing is in fact a very complex discipline, and also understanding which business case are more suitable for quantum techniques is not easy. So we recommend to our customers to develop this knowledge internally, but also contact trusted partners with which they can proceed in their quantum journey more quickly. So they can, of course, contact us to find out if our expertise is suitable for their businesses, and to have our support in identify which business opportunities are best suitable to be exploited by quantum approaches.
Exactly. Get in touch with people who know what they're doing. Well, thank you very much. This has been very interesting. I have certainly learned a lot. Johannes, Sara, thank you for your participation, and good luck in your work.
Thank you, Max, for having us.